Hello, I'm Domenico Napolitano, and today we're going to talk about Gibbs free energy. What is Gibbs free energy? Well, it's the amount of energy available to do work, which is depending on three factors. First, temperature, measured in kelvins, so is it hot or is it cold? Secondly, enthalpy, which is the amount of energy absorbed by the reaction, and there's two kinds. There's exothermic, so it releases heat, so like an explosion, it's like boom, and then it releases into the environment. Or there's endothermic, when it takes in heat, so let's say an ice cube, right? And then as it takes in heat, it becomes into water, which takes us to our third factor, entropy, which is the degree of disorder in a reaction. So let's say with the ice cube, right? As it took in heat to become a liquid, its molecules started moving, dispersing more. And then say you evaporate it and it becomes a gas and it's like, whoo, it's everywhere, right? Therefore, it's said to have a high entropy, which when you factor all three of them, you either get a delta G less than 0, which means it's spontaneous, so something's bound to happen, spontaneous without anything. We could have equilibrium, which is like, nothing really happens. And then third, when it's greater than 0, which means it's non-spontaneous. Now, this doesn't mean it won't happen, it just means that it won't happen by itself. This table shows the relationship between all three factors, the temperature, enthalpy, and entropy. For instance, when the enthalpy is low, so an exothermic reaction, and the entropy is high, it'll always be spontaneous regardless of the temperature. For instance, in thermite. Now in the second scenario, when the enthalpy is high, therefore an endothermic reaction, and the entropy is also high, the process will be spontaneous at high temperatures. For example, in this very cool reaction. In the third scenario, when the entropy is low and the reaction is an exothermic reaction, so it's releasing energy, it will be spontaneous only at low temperatures. For instance, with magnesium and dry ice. Now in this last scenario, when the enthalpy is high and the entropy is low, no matter what the temperature is, it will never be spontaneous. Now if you're curious on how a non-spontaneous reaction looks like, be my guest.